Hey, this is Fernando here. Here to do kind of just like a crash course on scientific notation. So things I'm going to show is going from standard form to scientific notation to standard form, kind of what that looks like in terms of the exponents of what goes to the left when you add, what goes to the right when you subtract. I'm going to show multiplying, dividing, adding, and subtracting. So you might need to skip around the video just to see what you need because I'm doing it all in one video. So if you're looking for the adding and subtracting, that's probably gonna be on the later half of the video, multiplying, dividing, around in the middle. So scientific notation, what is it, right? It's our ability to represent very, very large numbers or very, very tiny numbers in a very concise way that we can interact with, right? So what I mean by little big numbers or small numbers, right? A really, really small number would be something like this, where yes, we could always use this in a calculator, right? But if I had to multiply this number with a number that looks exactly like it, right? Your calculator is not gonna really be that happy with it. So we came up with this idea, right? Of representing this in a way where we're multiplying it by 10. It's like a version of itself by 10 and an exponent because it can represent all these zeros. So what does that look like? Well, scientific notation requires that you have one number in front of the decimal and it cannot be zero. So right now I see a decimal point and it's got a zero in front of it, right? So I want to bring this decimal point over to the right and it'll create scientific notation form by doing something like this where you count all the times you move the decimal. I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, right? So my new number is 4.5, right? If I want to get back to this number, you'd end up multiplying it by 10 to the negative 8, because that would be something like 1 over 10 to the 8th power. So you'd be dividing 4.5 divided by 10 to the 8th power, which is what creates this really tiny number, right? So one big thing I want you to notice is when you move the decimal point to the right, notice how we have a negative exponent. Moving it to the right means you are taking one away each time you move it. You're taking away one exponent away. So it's like -1, -2, -3, -4, -5, -6, -7, -8. That's what gives us our scientific notation. So that's a really tiny number. Let's see what a really large number looks like. This is not the largest number ever, but same idea, right? I got some zeros that I want to kind of not use or not represent with a solid number because putting this in a calculator would suck. So I'm going to find my decimal point right here. And likewise, I'm going to count how many times I end up moving it. 1, 2, 3, 4, 5, 6, 7. So my new number is 7.89, because again, you need just one number in front of that decimal point. You can't have more than that. Scientific notation is just one. So I moved it 7 times, right? So that'd be timesing it by 10 to the 7th power. Because if you actually represented this as a number and you multiplied this number, you'd end up coming back to this full large number. That zeros kind of help us doing that by multiplying by 10 or whatever this ends up being, like a million or so, right? And then again, notice how when I'm moving my decimal point to the left, how we're adding an exponent every single time. It's a positive exponent, right? Because it's going +1, 2, 3, 4, 5, 6, 7, which gives us our positive 7 number. So this is scientific notation, right? Going from standard form to scientific notation. Well, what if you want to reverse it, right? Like, what if we have a number that we want actually to see, what is this number representing, right? So negative exponents tell us that we have a very tiny number, and then you want to remind yourself that, I'm going to have a tiny number by the end because I have a negative exponent. I'm dividing it by something by 10 to the power 5. So because I'm going to have a tiny number, which way would I move my decimal point? I'm moving it in a way that would give me my tiny number, and I'm moving it 5 times. 1, 2, 3, 4, 5. So my decimal point would be right here, and I'm going to put zeros in those chasms. And, oh my goodness, I'm back to having my tiny number, right? This is my tiny number. By using it, that -5 exponent, I know how many times I have to move that decimal point. Same thing with very large numbers, right? Like, this is why the beauty of scientific notation. I'm starting with that 4.56, and from here, right, I know I'm going to have a very large number because it's a positive exponent. I'm multiplying it by like 1,000,000, right? So I'm going to be moving it 7 times. I'm moving it to make a large number, or go back to a large number of 1, 2, 3, 4, 5, 6, 7. So my decimal point would be right there, right? And so I'm going to have zeros where my chasms are. And if I erased everything, you'd see that my decimal point should be over here. And I'd have the original number, right? It's different than from the example ones, but that's the original number, right? Put your commas in here, and you'd see that we have 45 million and 600,000. So that is conversion of from scientific notation back to standard, or from standard, or a regular number, right, into scientific notation. So what if we have to multiply and divide, right? So division. We have a division problems where they can look like this. Again, 2 scientific notation problems. And then we also have multiplying scientific notation. I'm gonna go ahead and grab my calculator real quick, just because I want to make sure I have one. I'm smart, but not that smart. So we're gonna start with multiplying. And I would say, like, from here, you kind of have to remember a little bit of your exponent rules. Going over your exponent rules just really quickly. If I have x to the 2nd power times x to the 3rd power, if you broke that apart, right, that's what it's saying is x times x times x times x times x, which, if you combine all of that, right, everything's multiplying. What you're essentially doing is adding these together, right? You have a total of 5 exponents. So your final answer would be x to the 5th power, or that you're simplifying it to that. So that's an exponent rule, right? And notice how that's going to help us with multiplying scientific notation. What we have here is saying 9.5 times 10 to the 6th power times 4 times 10 to the 2nd power. What I'm going to be really focused in right here is what I kind of just showed off. Our exponents, because it's just a part of a multiplication sequence, you can just add the exponents together. What you're essentially doing is, because it's, if you tried spreading everything apart, this would be saying like 10 times 10 times 10 times 10 times 10. This would be saying 10 times 10. Simplified, that tells you it is 10 to the 8th power. So we're adding these together, right? Those get added together. And then the rest of this would be that this is still just a multiplication problem, right? So you can just multiply your constants or your regular numbers, right? It's a multiplication problem. Multiplication, multiplication, multiplication. So from here, you would 9.5 times 4 in your calculator, or if you go it off the top of your head, probably could have done that one, you'd have 38. Now, woo, you did the premise of multiplying scientific notation. You multiply your regular numbers, and you basically add your exponents together. But you got to remember our one little rule, right? That scientific notation requires that there's only one number in front of the decimal. Right now we have 2. So I'm gonna actually end up having to change this one a little bit and put it into scientific notation. I'm moving my decimal to the left, which means I'm increasing my exponents, my exponential power, and I would end up having a final answer of 3.8 times 10 to the 9th power. So this is going to be your final answer because it's in scientific notation form. This is great. You practice your ability to multiply scientific notation, but just remember that you gotta end in scientific notation. So I'll do another one. Same right here, because I want to show that when you have a negative exponent, what ends up happening, right? So from here, I'm going to just remind you that we are going to just straight up, let's multiply. Let's multiply our regular numbers, right? I would literally just go 3.3 times 5.4, and that would give me 17.82. So I know I'm gonna have to end up changing something here, but let's finish doing our exponents. My exponents, I'd be combining them, right? Or I'm adding them together. 3 combined with -8, right? Would end up keeping me in my negatives, right? Because you're adding those two together and you'd end up having -5, because 3 minus 8, -8, or if you want to think about it, -8 plus 3 would be you owing someone 8, paying them back 3, you're still in the negatives, 765, -5. So your final answer here would be, before we convert to scientific notation, you know you're on the right track when you've done this. From here, moving that decimal place over to the left 1, or increasing by 1. So my final answer here would be to -4, because I increased by 1. I increased my exponential by 1. So moving that decimal place over. Final answer being 1.782 times 10 to the -4th. So that's multiplying. Multiplying, right? Multiply your regular numbers, add your exponents, right? So think of those two things. When you're multiplying, multiply the regulars, add your exponents together, convert if you need to, or change your scientific notation if you need to. So from here, let's try doing dividing. Dividing and multiplying, the reason why I'm showing them together is because they follow similar rules, right? You want your regular numbers interacting with your regulars, and your variables, or your constants, not constants, your exponents interacting with your exponents. So showing off division again real quick, just the exponent rule that lets this happen. Let's say I have x to the 5th power being divided by x to the 3rd power. If I broke that apart, right, or if I expanded that, that's like saying x times x times x times x times x, and on the bottom you have x times x times x, right? So because I have 5 on the top, I have 3 on the bottom, our exponent rules tells us that kind of cross them out or subtract them, and you'd end up having x2 on the very top because you've canceled them out. You're subtracting them. Like you're able to subtract against them. And so you'd have x2. So same idea here, right? I'm going to use that exponent rule with dividing, and I'm going to show what that looks like for our exponents. So for this one, what I'm essentially doing is 10 to the 7th power minus 10 to the 4th power. You'd end up having left over, like if I just did this section right here, you'd have 10 to the 3rd power. It's like a separate part of this. You could write this as two different division problems, two different like fractions kind of. And you can separate this and just look at this to say 10 to the 3rd power. And then from here, if you're keeping it separate, it's just division. 7.8 divided by 1.2. 7.8 divided by 1.2. So, oopsie, I didn't write anything. 7.8 divided by 1.2 would give me 6.5. And that is my final answer, because I don't actually have to change this one. So we got pretty lucky. So divide the regular numbers or constants, subtract your exponents when we're doing dividing, So let's see if we can do it again, especially with a negative number here, right? So I'm gonna do my constants or regular numbers first. 2.5 divided by 4 would give me, so again, I divided these two numbers because it's a division problem, and I got 0.625. So this one, I'm gonna end up needing to change, right? And then I'm going to subtract my exponents. I have -6 minus 4 would give me -10. So my exponent is -10. Now, I told you right here, I'm gonna have to end up changing this one, right? So I'm gonna end up going decreasing, or I am moving my decimal to the right, meaning I'm subtracting one exponent, or I'm lowering down the exponential power to 6.25 times 10 to the -11th power, because again, I'm already at -10 minus 1 would give you to the 11th power. So again, moving to the right means you subtract 1. If you're going to the left, you're adding 1 exponent. And that's going to be really important now that we're going into adding and subtracting. So that is multiplying and dividing. Multiplying and dividing, kind of let's just keep this in mind that multiplying and dividing, you interact regular numbers or constants with regular numbers or constants, and then you use exponent rules to do your exponents, 10 to the power of whatever. So what if we got adding and subtracting though, right? So I have adding and subtracting problems. That includes scientific notation. I got 3.1 times 10 to the third power plus 4.3 times 10 to the third power. So here I have two different scientific notations. I kind of wanted to show you guys how scientific notation for adding and subtracting works, where unlike multiplying and dividing, where it doesn't matter if the exponents are different, the whole point of adding and subtracting means, I'm actually not even going to do that, your exponents have to be the same before you do anything. They have to be the same. So I gave you a problem where they're already the same, right? When they are currently the same, you can just straight up add or subtract the constants or the regular numbers. So I'm going to add 3.1 plus 4.3, right? And that's going to end up giving me 7.4. So I have 7.4. Now what exponent am I going to use? You do not add these. Like the reason why we're keeping them the same is because essentially you are adding 3.1 that is multiplied by 1,000. And you're adding that with 4.3 that's being multiplied by 1,000. So like those exponents are doing the same job. So the outcome ends up also being the same. So you're keeping the exponents that are matching, right? So what if they're not matching, right? What if right now this one has a 10 to the fourth power, this one has a 10 to the seventh power? Well, you gotta have to change it then, right? So right here and right here, because they're different, you need to change one of them. You can either add 3 exponents and change the constant, or you can subtract 3 and change the constant. My hint to you, or my suggestion is, always change the lower valued exponent. So whether that means it's further in the negatives or just the lower positive exponent, you want to change that. You come to me in class and just ask me to show it. I do just kind of want to show the changing of it. So right here, 10 to the fourth, 10 to the seventh. I want to change this to 10 to the seventh power. I want my final answer to have 10 to the seventh when I finish adding. When I finish adding my regular numbers. So you can't just do plus 3. You got to actually also change this. And so again, like I've been mentioning, whenever you move the decimal to the left, you are adding. And because we're adding, that means we're moving the decimal to the left. So you're going 1, 2, 3. 1, 2, 3. Make sure I got that right. So our new number is 0.00767 times 10 to the fourth power. That's my new number, right? And I'm adding it with 5.2, and we haven't done anything to this one, so this one's just being rewritten. Oops, this should be 7. So now it's just like the problem before, right? I've changed my number so that they have matching exponents. So this is where it comes easy, right? Like because these are matching, that's why this gets to be the part of the final answer. I want that 10 to the power 7. So from here, I'm gonna give my brain a little break. I'm gonna grab my calculator and I'm gonna add this number and this number. 5.2 plus 0.00767, and you'd end up getting 5.20767 times 10 to the 7th power. And we know we already have a scientific notation, so this is your final answer. So you got to change your the exponent if they're different. Once you've changed them, then you can add the constants or regular numbers. Let's see you do it with, I'm gonna just make sure I'm recording because I feel crazy. Thank goodness I'm recording. Sorry, that was a sanity check because it's been so long into this video. So I'm doing a subtraction problem, right? And let's start with this one. So same idea, right? I got two scientific notations. I noticed that I have non-matching exponents. So I gotta change one of them. I suggest changing the one with the lower exponent. So this one, I want to also add 3 exponents so that my final answer will have 10 to the 5th power because they'll be matching, right? And that means I gotta change this though. Because I'm adding 3, I'm moving my decimal point 1, 2, 3 times. So this is my new number, right? This is my new number that's attached to this scientific notation, times 10 to the 5th power. And I am subtracting it from 1.39. Because I didn't change anything. They have matching exponents, so I can actually just subtract them. 1.39 minus 0.004. I guess I could have just done that as well in my head. 1.386 times 10 to the 5th power. Again, this gets to be here because we changed the exponents to be the same. I changed my decimal so that it can be interacting with the other one. 1.39 minus, because it's subtracting now, 0.004 is your final answer. And we don't have to change anything. This one is, you don't gotta change. And then finally, let's just do one last one. So again, they aren't matching. I gotta change one of these. I'm going to add 3, 6, 7, 8, and I'm going to end up changing this one by 3. 1, 2, 3. So my new decimal is 4, 4, 5, 8. Long decimal, right? And it's being subtracted from 9.3. And the exponent that I'll be using in my scientific notation final answer is going to be 10 to the 8th power. So let's see what I end up getting. 9.3 minus 0.004458 would end up giving me, I'm going to give myself some room, 9.29552. And I'm going to have to move all of this a little bit because my final answer would be this in scientific notation form. So there you go. That's all of the 4 operations with scientific notation: subtraction, addition, multiplying and dividing, converting from standard to scientific notation to standard form. Look at this video if you need help for your quiz. Biggest notes: adding and subtracting. Make sure they're matching so that you can use that exponent and put it in your final answer, and then add or subtract them. Multiplying and dividing. You get to, when multiplying, add the exponents, multiply the constants. When you're dividing, subtract your exponents, divide your constants. And again, I'll just leave you off with this. As if you're gonna remember anything for this conversion, moving your decimal to the left means you're adding an exponent every single time you move the decimal. You're adding an exponent. And when you're going to the right, you are taking away an exponent, or you're lowering your exponential power. Best of luck. Thank you for watching.